Alright, well, we're going to attack the second part of section 1-2. Remember, we were talking about functions and a lot of general, generic kind of ideas about functions. What the second part of this section is about is kind of some, I don't know if I'd say families, but some characteristics or some unique qualities, I guess I would say, of certain kinds of functions. Things that some of them have in common. So we're going to look at 3 different kinds today. The first kind of function or family of function is what we call step functions. And step functions are just any kind of function that when you graph it, it resembles a set of stair steps. So you think about in your mind what stair steps would look like. All right, either steps going up or steps going down. Okay, so that's just what a step function is. So I don't know, probably the one that's most well known, or the one at least I've heard of the most, is called the greatest integer function. The greatest integer function is also referred to sometimes as the floor function. Maybe we'll get an opportunity to understand why it's called the floor function here as we go through this. All right, the floor function. The floor function is symbolized with this kind of funky notation here, almost like brackets with an extra line going down. All right, and what that means, what the greatest integer function is if you put a value in for x, all right, it's going to return the biggest integer that is less than or equal to that value of x. Okay, so think about it in your brain. If you have to go back and listen to it again, push pause, rewind, go back over that. The biggest integer that is less than or equal to whatever value you've put into the function. Okay, so I'll give you a couple examples here. This doesn't have to be any particular function. I'm just going to make up an idea here until you understand what I'm talking about. All right, so suppose I have some function, all right, and again, I'm just giving you an example what to kind of think about here. But if I put in, let's say 0, well, the biggest integer that is less than or equal to 0 is 0. All right, so I would put a dot at 0, 0 on my graph. Let me finish up and put the rest of the marks on my graph here so you have an idea. So start to think about why we're given the value for the function that we're getting. So if I put in a half, so think about that. What integer is less than or equal to a half? And that would be 0. Okay, so I have a dot there. In fact, I could put any value I want from 0 up through whatever decimal you want, from 0 to 1, and it's always going to drop back down to 0. All right, it's always going to be the value that is less than or equal to that value. Now, if I get to 1, well, the number that is less than or equal to 1 or equal to is 1. Okay? But for any value from 0 to 0.99999, it's going to give me 0 for an answer there because it's always less than or equal to that value. So I'm going to put a solid line on my graph from 0 up to as close as I can get to 1, but not quite touching 1, because if I get to 1, it's going to jump up to 1 for an answer. So I'm going to leave an open dot there. Remember open dots back from when you did some graphing last year in Algebra 2 or even a couple years ago in Algebra 1. Open dot means that that value does not work. Okay, so I show you a couple steps here. All right, what about the negative values? Be careful on these, because if I have a negative 1/2, that's going to drop it down to -1. All right, and again, just like before, I can have any value between 0 and -1. Any value in there, -0.9, -0.7, -0.3, anything in there, it's going to go down to -1. Be careful on those. So I'm going to have a solid line in there from 0. Again, I'm going to have an open dot at 0, because if I get to 0, obviously the answer is going to be 0. All right, if I have -1, the answer is going to be -1. So when I do all this, when I finish this graph, you'll see this is why it's called a step function, because it resembles a series of steps, some ascending steps as we go from left to right. All right? Try to understand why those are either closed dots or why they're open dots. That might be a question that you have for me in class tomorrow, if you're struggling with that idea. Okay, so what I'd like you to do is I'd like you to try to graph. Oh, I spelled your wrong there. Sorry about that. Try to not mind my English there. All right. Try to graph this function, the greatest integer function of 2x plus 1. So push pause on the video right now and graph that function, and then we'll talk about that tomorrow in class. If you weren't sure exactly how to graph that, bring that up tomorrow in class. Ask me on that, and we'll go through that together. If you struggle with that at all. All right. So a good time to push pause right now. Try that, and then when you're done, go ahead and resume the video. All right, so hopefully you're able to do that, or at least got some of it done, so we can have a conversation about that in class. Second kind of function we're going to look at on the video tonight is piecewise functions. We talked about a little bit about piecewise functions the other day. I remember piecewise functions are simply functions that have some restricted domains to them. All right, different pieces, if you will. Okay, so for this particular piecewise function, it's going to have 3 different pieces to it, 3 different parts. Alright, when x is less than or equal to 0, the function is defined by x minus 3. When x is between 0 and 1, not inclusive of those numbers, it's just going to be negative 3. And when x is greater than or equal to 1, the function is defined by negative x minus 3. Alright, and so I just want to work on graphing this. Try to get you to understand how to graph a piecewise function if this is difficult for you at all. And you'll have some examples of this in your homework tonight. So the way I do it, at least the way I'm going to instruct you on this right now, is to use some different colors for different pieces, so you can kind of see how the pieces fit together, what part goes with each component of this function. So what I'm going to do here, get my graph all laid out here for you. And so for this first part, all right, anytime x is smaller than 0. Alright, I'm going to use that first function. So it has a y-intercept of negative 3, has a slope of 1, so either go up 1 to the right 1, or I can go down 1 and to the left 1, and that would be my graph. It's just a linear function. And that would go on forever and forever to the left, because this is any number less than 0. Okay? From 0 to 1, it's a constant function. So a constant function is just going to be a horizontal line from 0 to 1. Now, when I get to 1, it's not including that. So, should that be an open circle or should that be a closed circle? Well, since it doesn't include 1, that really should be an open circle right there. That's an open circle. It does not include that. You might say, well, why is the circle closed at 0? Well, it was closed because of the original function. The first function was defined at that spot. Alright, again, that might be a question that you look for some clarification tomorrow in class. And then for the last piece, anytime x is bigger than 1. Alright, so if x is bigger than 1, I'm plugging the 1 in, so the opposite of 1 is negative 1, minus 3 is negative 4. And then from there, I have a slope of negative 1, so I'm going to go down 1 and to the right 1. And so I'll have that linear function going down like this. Alright, so those are my 3 pieces. So what is that? How does that look? What does it look like when it's all said and done? I'll just use a yellow here to kind of trace it all. Alright, this is what my function would look like. I have a solid dot right there. It's going to go forever to the left. I have this flat spot with an open dot there. I have a solid dot at that spot. And so anywhere you see the yellow function right now, that would be the entire g of x, the entire piecewise function defined. Alright. Some people understand that really well. They understand the different parts of it, the different domains, the restricted domains. That's an important term to be able to use. This domain is restricted over these numbers. Alright, but again, you'll get some practice with that with the second half of this homework assignment, working on graphing those piecewise functions. Alright, the last idea I want to talk about and discuss and try to instruct you on is the difference between even and odd functions. Alright, even and odd functions. Not every function is going to be even or odd, but there are some functions that are defined as even or odd. Alright, an even function. is defined when the f of x always equals the f of the opposite of x for any x value you plug in. Alright, so the f of x and the f of the opposite of x are equal to each other. Odd functions are defined when the f of x is equal to the opposite of the f of the opposite of x for any value that you plug in for x. Now, I'm going to guess, unless you've heard this before, that might be a little bit confusing. So let me give you an example of each of these two functions, just so you can kind of see what I'm talking about here. So an example for the even function. So again, I'm just going to make up some numbers here, but this is what your result, this is what your output should look like. Alright, so and I don't really need this part here. Let's get rid of that. Alright, so if I have x, I have f of x. So give me any value for x. So suppose I say x is 1. I plug 1 into the function. Let's say I get 7 out. If I plug negative 1 in the function, I'm going to still get 7 for an answer. If that happens for every value of x, if I always get the same answer when I plug a number in and its opposite, you can see here's another example, then I would say this is an even function. But remember, it has to happen for every x and its opposite. Okay, so if I take 4 and I plug 4 in and I get a certain number, and I plug negative 4 in and I get that same answer, all right, then that's confirming that function is an even function. All right, so here's an example of an odd function. Maybe you can figure this out already if you understand that notation I gave you earlier. If I plug in a value, if I plug in 1, let's say this time when I plug in 1 I get 12. If I plug in negative 1, I should get negative 12. Again, it's the opposite. All right, not too hard to see that those are opposites there. Okay, if I plug in 4 and I get negative 6, and I plug in the opposite of 4 and I get positive 6. Since those are opposites, then that confirms that this would be an odd function. Again, remember, this has to be so for every value of x that you could plug into this function. Anything that you could plug in and get an answer out has to work for this. Alright? I want you to think what that would look like. Like what would that look like as a graph? Be thinking about that. I'm going to come back to this before we're done. Be thinking about what a graph of that would look like, so that you wouldn't have to plug all these values in. Okay, so what I'd like you to do, a little example here, a little practice here, I want you to tell me which of the following functions are either even functions, odd functions, or neither one. Alright, again, like I said before, functions don't have to be odd or even. They might not have that characteristic when you start plugging those points in. So tell me which of these functions is odd, even, or neither. What I want you to try to figure out is, as you do this, is there a way that you can determine if a function is going to be odd or even just by looking at the graph of it? Alright? So I really want you to pay attention to that. So push pause on the video here as soon as you see these three functions. Plug some points in, graph them, alright? Determine based on the results that you have, is the function odd, is the function even, or is it neither? And then again, I want you to think about is there a way that you can determine odd or even without having to plug in a whole bunch of values? Alright, and this is something I think we're going to have to talk about tomorrow in class. Remind me about this, alright, because I really want to see if you were able to figure out, based on your graph, what the answer is to that question. Okay? If you want to get a head start on the homework assignment for tomorrow, then we'll have time in class to work on this, but if you want to do a little bit of it tonight, it's page 94, numbers 83 through 96, and 111 to 134. Alright? So, good luck with that, and we'll talk to you tomorrow in class.